Hello guys, today we will be learning about inductors. So what is an inductor? An inductor is a component in an electrical circuit which typically consists of an insulated wire wound into a coil and stores energy in a magnetic field when there is a current flowing through it. The basic principle behind an inductor comes from Faraday's law of electromagnetic induction and Lenz's law. Faraday's law states that whenever a magnetic flux varies, a EMF is induced, and hence a current is induced within the conductor. The magnitude of this EMF is directly proportional to the rate of change of magnetic flux. Lenz's law states that the induced EMF and induced current developed in a coil always opposes the cause of flux change. So how do we measure inductance? Inductance is measured in Henry H, and it determines the strength of the magnetic field around the coil due to the applied current. Inductance is given by the formula, where mu, permeability N, number of turns A, area of the coil L, length of the coil. Energy stored in an inductor is given by. Let's look at how an inductor behaves in a DC circuit. When an inductor is connected to a DC voltage source, its behavior changes over time. Initially, when the switch is closed and DC voltage is first applied, the current in the circuit does not increase instantly. This happens because the changing current in the inductor creates a changing magnetic field. According to Faraday's law of electromagnetic induction, a changing magnetic field induces a voltage across the inductor. This induced voltage is called back EMF. This happens due to Lenz's law. Here it opposes the increase in current. Because of this opposition, the current in the circuit increases gradually instead of immediately reaching its maximum value. The voltage across an inductor is given by the equation, where L is the inductance and dI by dt represents the rate of change of current. After a long time, the current becomes constant and no longer changes. Since the current is no longer changing, the induced voltage across the inductor becomes zero. At this point, the inductor behaves like a short circuit in a DC circuit and allows current to pass through it freely. For example, in a circuit containing a resistor and an inductor connected to a DC source, the current increases gradually according to an exponential curve. The rate at which the current rises depends on the time constant of the circuit, which is given by the equation. Inductors are used in various places, such as in induction motors, transformers, filters, and many other circuits. I hope this helped in your understanding of inductors. Thanks for watching.